Hi and welcome to the channel, it's great to have you here. Today on the channel we're going to be making this awesome fun little sound effect machine. Now this will be a great next step project if, for example, you've just finished going through all the examples, the sample projects that you got with your kit when you bought your first Arduino Uno. For example, I got this kit from Amazon and it contained the Uno, various different sensors, like this ultrasound proximity distance sensor, this relay unit and things like that. Now the sample projects that come with those, they're great for learning, but you never really end up with a finished product. So that's why today we're going to be learning how to make this, which as you can see is a nifty little finished product. The unit itself, like I said, is a sound effect machine and it can produce various different sound effects. In fact, it can store up to 128 megabytes of different sounds, and these sounds will be stored as WAV files or MP3 files, and they can be downloaded onto the unit just by using a USB interface on your computer. But we'll get to that later. Now, as I was saying, this is be a great next step project to create after you've finished doing the sample projects that came with your Arduino Uno. And I do mention the Uno, but we won't actually be using the Uno today in this project for a couple of reasons really. I think the first reason is that the Arduino Uno itself, as you can see, it's quite a sizable thing and it wouldn't be very much use. It wouldn't even fit in this project box. The Uno, it's very good for starting out as it's got the pins broken out into these wire sockets so that you can connect up your cables and connect them to the different sensors. But really, this unit's only very good for prototyping, and it's you wouldn't really use it in a finished project. What you would do is create your project using the Uno maybe, make sure your code worked, and then you would find a different microcontroller to house the finished product on. In this case today we're going to be using this little fella. This is an Arduino Nano. This one doesn't have the pins soldered onto it yet. Now the Nano is, I would call it the little brother of the Uno, but I think has it got even more pins? It's certainly got just as many, and it's a total fraction of the size. Look at the size difference. Yeah, so this is definitely more viable for going into finished products, and as you can see, it will more than easily fit into this project box that we've got here. Now, I have been mentioning the word Arduino a lot, but whether you know or not, Arduino is actually open source, which means that they allow everybody to copy their boards basically and use their architecture on their own boards. So as you've probably noticed already, this isn't an actual Arduino board, but it's made by a company called Elegoo, and it's a copy of the Arduino R3. But it's just a cheap clone that's made in China, and I think these are fantastic. They're great quality. You can't tell any difference. They work with the Arduino IDE. Similarly, this is also a Chinese copy, and just as good. I don't see any difference. I don't see why you would buy the official Arduino ones unless you wanted to support the foundation. I suppose would be a good reason to. This is just two of the microcontrollers that we'll be using on this channel. A couple of more examples. We'll be using things like this. This one is a Wemos Mini D1. I think these little units are fantastic. You don't get as many pins to use in your projects, but they still have the I2C bus, and they still have a UART serial interface, all of which we'll talk about in other videos. But for this unit in particular, actually has Wi-Fi built in, which I think is fantastic. So you can use this to create a web server, have it hosting some data from various sensors, feeding data back to a central unit, or hosting a web page that you can check. The possibilities are endless. The good thing about all these three units that I've showed you so far is that they all have USB interfaces, which makes it easy to send your code over on the Arduino IDE. I said this was the little brother of the Arduino Uno. Well, this itself has a smaller version again, and it's called the Arduino Pro Micro. It's about 2/3 of the size of this. So you lose some pins again, but you gain the small size. The only downside of boards like that is that they don't actually have USB on board. So to program one of those, you would need something like this, which is a USB to TTL adapter. And the way that works is you plug your USB into here, plug it into your breadboard, and then the Pro Micro has a similar pins on the bottom, and you plug that in, and then you use the Arduino ID to send over your code using this serial interface. They're all things that we'll get to in different videos, but today we're going to focus on building this funky little contraption. I hope you're as excited as I am. So the first thing we're going to do is list out the components that we need to put it together. So let's look at that now. Okay, so these are the bits and bobs you're going to need to follow along with me and make this device. First of all, we need a project box to house the project in. Next, we're going to be using the Arduino Nano as the brains of the operation. Next along, we have an 8-ohm 2-watt speaker, just a small little speaker like this. Next, we've got the main component, which is the DF robot. This is a DF Player Pro. Can be had for a few pounds from Amazon. I'm going to link to all these components in the description. They're all from Amazon. They can all be got quite cheaply, and they're readily available for anyone to buy. I don't know if you're planning to make this project, or you're just going to watch, or just going to use it for some inspiration as things that can be done. Simple projects after you've finished making the sample circuits that came with the kit that you may or may not have started with. On top of that, we need a push button, just a simple momentary switch, 3.7 volt LiPo battery, and this is just a female JST connector for connecting the battery to the circuit. On top of this, you'll need some wire, obviously. I'll leave a link to this one in the description too. Obviously, you're going to need a soldering iron. Hot glue guns are useful to have, and also a Dremel would be useful just for drilling the holes in the box. And also in these little boxes, there's a few, I'm not sure if you can see those, there's some small risers there to screw screws in, I'm guessing therefore, but they just get in the way, so we're just going to cut those off with the Dremel. Okay. Alright, so now you've got all your bits and bobs together, let's get started. Alright then, so the first thing you want to do, as I said before, is cut off the little nubs that are on the bottom of the box there, and also on the lid, just to give us some more space to work in. The way it's going to fit together inside the box is that the DF player is going to sit against the Nano like this, and then they're going to go into the box lengthways like that. To stop any interference or any electrical short circuits, we're just going to pop a piece of tape over there. So anyway, the first thing I would do is drill 7 small holes in the front of the case to allow the sound to come out, like we've got there. And then you can use the hot glue gun to mount the speaker flat against the bottom of the box, in that manner there, like that. Okay. Now you want to drill a hole in the top, and I'll do the same, mount the switch. The bottom pops off, pop it through your hole, use hot glue gun to secure it to the underside, like we've got there. Okay. And now the way the circuit works is the bottom 2 right hand side connector the pins down on the Arduino Nano, you'll see RX and TX. That stands for receive and transmit, and that's the serial interface, and that's what we're going to use in the code, which I'm going to show you shortly, to talk to the DF player. Similarly, on the DF player on the left hand side, the 3rd and 4th pins down are RX and TX. So positioning the two, holding the two like that, you want to measure a length of wire, and then we're going to want to connect RX to TX and TX to RX. So you'll have those both soldered together like that. They'll just be placed on top of each other, a piece of tape over the top of the Nano to stop it shorting out, and they're going to be on top of each other like this with a short wire soldered from the RX to the TX, TX to the RX. Next, we want to solder the speaker wire to the L plus and L minus pins on the DF player sorry, this is the speaker. Yeah, so solder those two wires onto the speaker like that. And then the only other thing to do is to connect the power and the switch. So with the power connector, you want to solder the red connection to the 5-volt pin on the Nano, and then take another wire from there, go into the V in on the DF player. So daisy chaining them along. And then we want to take the black wire from the power connector and solder that to the ground of the Nano, and daisy chain that onto the ground of the DF player. And then also we want to take a wire from the ground leading up to one of the pins of the switch. You can see how it all goes together here. My DF player already had the pins soldered onto it, so I've had to put them in and bend them over like that. You can see that the black and the red go to the black and the red and the Nano, and the TX and the RX go to the TX and the RX on the DF player as well. We have one wire going from the black ground up to one side of the switch, and on the other side of the switch you want to solder a wire that comes down and solders onto pin number 2 on the Arduino, and that's what we're going to use to trigger the device to play the sound. Okay, and it's as simple as that. I'm going to show you this again. You can have a good look. We just use some tape in there for insulation. All fits together. You can see the speaker there glued into the bottom. Obviously take care to get no glue on the front side of the speaker, otherwise it won't be able to vibrate and make sound. We've got all the 3 black wires there, one going to the battery connector, one going to one side of the switch and one going to the DF player. The red, one going to the battery and the other going to the DF player. And then you've got the 2 serial cables connecting the serial pins together. And you'll find that that fits in there just like that. We're going to move over to the computer in a sec and get the code, but once you've put it all together like this, you can connect the battery. Music. And you'll know that it's worked because the DF player seems to say music when it's first turned on. All right. Put the back on, and one short press makes the sound. And a long press moves into the next sound in the memory of the DF player. It's got 128 megabytes of memory, and it doesn't need a memory card or anything. The memory's on board the DF player itself. The way where I got my sound effects from, I just downloaded them from YouTube. Won't say too much about that. I'm not sure if there's any copyright involved in that. I wouldn't have thought so in such short sounds, but it can take MP3 files, WAV files, and all you do is just connect the DF player with a USB cable to your computer. It appears as a flash drive, and you just drag your sound effects onto there. And you'll see in the coding in a moment that it doesn't reference them by name. It references them by order that you copy them onto the DF player. So the first one that you copy onto there will be number 1. Second one will be number 2. Third one will be number 3. It doesn't matter what they're called. The first one that you copy onto there will always be referenced as number 1 in the code. So if we tell it to play file number 1, it will always play the first one that is copied onto there. I hope that's clear. I think it is. Okay, so now all we need to do is to write our code, download it onto the Nano, and then we're good to go. So let's move over to the computer now and see how that's done. Before we continue, I almost forgot, here's a schematic to help you make the circuit if that's what you're doing. I'll just leave this on the screen for a moment. I don't know if you want to pause it or take a copy of it or just have a look for your interest. It might be a bit clearer than my descriptions was before. So it just shows where to connect to the cables. I'm sure you know what a schematic is. I'm just waffling now, so I'll just leave this on the screen for a second. And you can see where things need to be connected to complete this circuit. Again, it's a really simple one, but it's quite fun, and it's useful having a finished product rather than just a sample circuit that doesn't do much. Okay, so alright, now we've said that, let's get back over to the IDE and get some coding done. Alright, here we are in the Arduino IDE. I'm sure you're more than familiar with this. We've got our board set as Arduino Nano, because that's the board that we're going to be using. I've not got mine connected at the moment, but when you connect it, as I'm sure you're aware, you will choose which port it's connected to there. So what we're going to do first is include the library for the DF player. So we do that by this line here. Just include the DF robot DF1201S library. And then we're just going to define this variable as the serial interface, just so that when we start talking about this, we're talking about the serial interface. Then we're going to create an object using that library, and we're going to call it DF1201S. That's how we're going to refer to our DF player later on in the code. I'm also going to include a library called EasyButton. This is really useful for debouncing buttons. I'm not sure if you're aware what button bounce is, but when you press a button, you don't notice, but the mechanism inside bounces up and down a couple of times, and if you're not careful, the code is running so fast that it can detect that as 1 or 2 or 3 presses when you don't want it to. So you have to do something called debouncing the button, and rather doing that yourself, it is quite easy to do, but just be lazy and just include this EasyButton library. It also helps us when we're noticing long and short presses in a little while. So talking of long and short presses, we just need to define the amount of time that we class as a short or a long press. We're going to do that by creating 2 integers, one that's called short press time. We're going to define that as 1000 milliseconds, which is obviously a second. And for the long press time, we're going to change that to 3000, so we'll call a long press, oh, what's going on there? And we'll call a long press 3 seconds. Okay, so a long press is going to be 3 seconds, a short press is going to be 1 second. I'm just using this variable pix. We're going to set it initially as 1, and this is just going to hold the number of the track that we're currently playing on the DF player, and the total tracks is going to be stored in this variable. We're going to set it to 4 for now, because that's the amount that I started off with when I first wrote this code. But as you can see later on in the code, we're going to be overwriting that anyway, because it's going to be detecting the amount of files that are on there. So next we're going to create an EasyButton object called button, and we're going to define it as being on pin 2. If you remember before, we connected the button to pin 2, and the other side of it is connected to ground. So basically when you press the button, it's going to connect pin 2 to ground, and then this is going to detect the button press. Next we need to define a couple of more variables, but these are going to be quite large numbers, because these are going to hold the time in milliseconds since the board was turned on. That's gathered by a function called millis, which we'll be using further on in the code. I'm sure you've come across that before. So we're going to define a variable called press time and one called release time. I'm going to set them to 0. And then in the setup, we're going to use a function of the EasyButton library just to define the bounce time, the debounce time. So we're going to set that to 50 milliseconds. Using this line here. That means that any presses that are quicker than 50 milliseconds, we're just going to ignore them. Okay, and then we're just going to begin the serial connection to the DF player at the board of 115,200. And then we're just going to use this little loop here to wait until that's started. You probably know that the exclamation mark is a not in C language, which the IDE uses here. So that's basically saying while it's not started, then loop. Okay, so and then we're going to do a couple of setups on the DF player itself using the object that we created earlier. So we're going to set the volume to 20. That's just in there as a little reminder to me what to set it to. I think the maximum is 25, so I found 20 a decent volume without making the speaker blow or anything like that. Don't get any distortion. We have to switch the function to music using this command here, and then we just have a delay of 2 seconds for it to set itself up. That's when you'll hear it say music. When you first turn it on, you hear it say music, music, and it's just doing that to let you know that it's ready to go. So then we're going to set the play mode to single, because when we press the button we just want one sound to come out of there rather than it to keep looping through the different tracks on there. So we use this line to set it to single play mode, and then we're going to use the function getTotalFile to store the total amount of files in the total variable that we created just now. So from after this point, that variable total will be equal to the amount of files that are on the DDF player, which will be useful further down in the code. So we come to the main loop, and the first thing we do in the main loop when we're using the easy button library is we just call this loop function button.loop. For some reason you have to call that when you're using the easy button library, and it has to be the first thing in your loop. I don't know why, it doesn't explain that in the library itself, but it just tells you that you have to use that line the first thing in your loop. So that's what we do there just to get that going. Okay, then we're just going to say that if the button is pressed, it's going to store the millis, which is the number of milliseconds we've been running for, in the variable called press time. And then if the button is released, we're going to store the milliseconds that the board has been running for in the variable release time. And then what we can do is find out the duration that it was pressed for by taking one from the other. I hope that makes sense. So in the press duration now, we end up with the amount of milliseconds that the button was held down for. Obviously, if the button was not held down, then it will just continue through there and then loop back to the loop, and we'll keep going round and round. So now we're going to say that if the press duration was shorter than the short press time, so basically if we've just pressed the button for less than 1 second, then we're going to set the play time to 0. We're going to play file number pix, which will be equal to 1 at the moment, so we're going to play file number 1, and then we're going to set the play time back to 0 ready for next time again. Then there's a short delay of half a second. And then if the press duration was longer than the long press time, so if you hold it down for longer than 3 seconds, then it adds 1 to the pix variable, i.e. moves on to the next number. And then if the pix is bigger than the total, so if the track number that we're wanting to play is bigger than the total, then just take it back down to 1. That allows you to cycle through the total files on there without causing any errors. And that, my good friends, is it. I told you it was simple. So I will leave a link to the code in the description as well, in case you're really lazy and all you want to do is just make it work. You can just download the code yourself. So once you've got that popped into your Arduino IDE, all you have to do is, I'm sure as you know, click there to upload it to your board. And then I would also after you've done that, connect your DF player to your computer, upload some sound files, some WAV files or some MP3s onto it, and you're cooking with gas. So let's just move back over to the table now and we'll wrap up. All right, thanks for watching. Okay, great. Hopefully you've downloaded your code onto the unit now. You've uploaded some sounds, you've put it all together, and you've ended up with a finished project like this. Hopefully that's given you some inspiration or some ideas of, it's a really, really simple project to make. Shouldn't be too tricky at all if you've just completed the samples that came with your unit. Maybe this is your first or second attempt at soldering a finished product. Maybe you needed some inspiration of an idea of what to make. I know that can be hard when you've... Sorry about that. I know that can be hard when you're first starting out of thinking of ideas of things to make. But here at Gizmos and Arduinos, we've got tons of useless devices that we've made. But at least they're all finished products. The next video I'm going to show you how to make this, and we'll go a little bit more into depth in this one. I think this is a copy of you remember the Simon game? I don't know if you're old enough to remember the Pocket Simon game that used to be out. Basically, once you press start, it produces a sound and a light, and you have to copy it. And each time it adds 1 onto the sequence, and the sequence will get faster and faster. And the idea is you just keep going as far as you can. It's just a fun little game. Again, really, it's not the destination that we're interested in. It's the getting there. It's the making of these things that are fun, and just knowing that you can make something yourself. Dead. And you can check your high score by pressing this. It flashed the amount of times that your high score was. I think we scored 4 then, did we? Yeah, 4. And if you score more than 4, then you get more flashes than that. It's quite simple again to make, a little bit more in depth than this unit though. So that's one of the next things we're going to be making on the channel. So hopefully you can join me for that one. This was the first YouTube video that I've made. I hope I've done alright. Leave me a like if you think I deserve it. Subscribe to the channel if you want to know how to make more useless fun stuff, I should say. With all that being said, thanks for watching, and catch you on the next video. Bye for now.